Hi Algebra 2 friends, this is just a quick test review video based on what we did in class, so let's find the vertex. And yeah, these numbers are a little bit large, but that's okay, you're going to push through. So if we want to find the vertex here, I think what I would do first is I'd use the vertex formula. Remember the vertex formula, opposite of b over 2a. So a, b, and c. A is -8, B is -80, and C is -199. So opposite of B, opposite of 80, -80 is 80, over 2 times 8. That is -16. And 80 divided by -16 just happens to be -5. So we get an x-coordinate of -5. And then we will put that in with the y-coordinate. How do we find the y-coordinate? We plug it in. We substitute in x equals -5. So y equals -8 times -5 squared minus 80 times -5 minus 199. Remember to follow order of operations here. -25 squared, or -5 squared is 25. -8 times 25. That is -200, and then -8 times 5 is plus 40 minus the 199. Now, to make our, I thought I was going to make our lives easier, but I'm not. All right, -200 times, or plus 40 is -160. So -160 minus 199, that I'm going to write it so I don't mess it up. 5, and that is -359. -359. Now, crazy numbers. We're not going to graph these, but think about what this graph would look like. First of all, if our A term is -8, this parabola would open down and it would be very, very tall and skinny. Our C value is -199. That means our y-intercept is at 0, -199. So that makes our vertex make a little bit more sense. So we will have some to graph. You can look back at other videos to practice the graphing. Next, we've got simplifying with imaginary numbers, complex numbers. So we have a fraction here, and we have a two-term complex number on the bottom of the fraction in the denominator. We need to multiply by the conjugate of the denominator, which is 4 minus 3i, over 4 minus 3i. So we are going to need to use the distributive property here. Some people call it FOIL, which represents first sides, outsides, insides, last sides. I'm going to do that now. 3 times 4 is 12. 3 times -3i is -9i. -2i times 4, -8i. -2i times -3i plus 6i squared to the bottom. 4 times 4 is 16. 4 times -3i is -12i. 3i times 4 plus 12i. 3i times -3i, -9i squared. Good news, 12's cancel. This guy plus 6i squared, since I squared equals -1, plus 6i squared will just become -6. Minus 9i squared will become plus 9. So now we are able to combine like terms. So that will be 12 minus 6 is 6. -9 and a -8 is -17i, all over 16 plus 9 is 25. So remember, we always put the real in front of the imaginary. So, next problem, I to the 55th power. Now, always keeping this fact in mind, we're going to rewrite I to the 55th using this. So, I to the 55th is I to the 54th times I to the 1st. And then we will use I squared and the properties of exponents to rewrite I to the 54th. I to the 54th, if I can get my pen to cooperate here, I to the 54th is I to the second, there we go, I to the second raised to the 27th power times I. So if we've got I to the second, of course, that is negative 1. So we've got negative 1 to the 27th times I. So negative 1 to an odd power will stay negative 1, and negative 1 times I is negative I. So I to the 55th reduces to negative I. Use I squared in order to rewrite powers of I. Last two problems are solve problems, and when we solve, we're going to factor or complete the square. And neither of these are going to be factorable, but we are going to be able to complete the square with both. So the first one is a simple one. So first of all, we have a 1 up front. That's critical. So our next step would be to get those constants all on the right-hand side. So we end up with x squared minus 10x plus a blank equals 8. It's already there. Minus 26 plus that blank. Now, we'll deal with combining all the like terms on the back end here. Let's focus on the middle term. That middle term is 10. Remember, we take half of 10 and square it. Half of 10 is 5, and 5 squared is 25. So we are going to add 25 to both sides. We're adding 25 to both sides. So now we've got x squared minus 10x plus 25, which easily factors. Factors of 25 that add up to negative 10 are x minus 5 and x minus 5, or x minus 5 squared. On your right-hand side, we've got a negative 26 and a positive 25. That's negative 1. And 8 minus 1 is 7. So now we've got x minus 5 squared equals 7. So what do we need to do? Both sides, we now need to take the square root, and the square root undoes the square, so we get x minus 5 equals positive or negative root 7. Root 7 cannot be simplified, so it just stays plus 5 plus 5. X equals 5 plus or minus root 7. So that is our solution set. Next problem, a little bit more work involved here. First thing we got to do, we got to get it set up. So we need to drag this plus 30x back over to the left. So that will be 3x squared minus 30x equals the negative 4. Now, remember, we need to take out the a term, all right? So let's dump it in this case, because remember, we are solving. We're not just rewriting, but we are solving. And when we're solving, we want our a term to be 1. So divide by 3, divide by 3, divide by 3. Cancel. So we get x squared minus 10x equals negative 4/3. How handy. It's going to be the similar type problem, but we got a fraction. So remember, fractions are our friends. Let's just learn to love them. So we are going to complete the square here. So let's go ahead. I left us room for a blank and a blank. And now half of 10 is 5. It's negative. It doesn't matter because we're going to square it. Half of 10 is 5. 5 squared is 25. We're adding 25 to both sides. So it factors just the same on the left-hand side. But on the right-hand side, we've got negative 4 over 3 plus 25 over 1. We need a common denominator. That common denominator is 3 times 3 times 3. So we end up with negative 4 over 3 plus 75 over 3. That is going to give us 71 over 3. 71 over 3. And now, when we take the square root of both sides, we get x minus 5 equals plus or minus the square root of 71 over the square root of 3. Yes, I am breaking it apart because I do want to remind you that we do need to rationalize the denominator. And when we rationalize the denominator, we're going to need to multiply by root 3 over root 3, which of course is equal to 1. So what does this do for us? We get x minus 5 equals plus or minus 71 times 3 is 213 all over root 3 times root 3 is 3. We have one last step here to solve for x. It is to add 5. So x equals 5 plus or minus root 213 all over 3. And that is our simplified, rationalized answer. Last problem here. Let's rewrite this quadratic function in vertex form. So right now it's in quadratic form. So A is equal to 4, B is equal to 24, C is equal to negative 5. So when it's in quadratic form, none of the secrets are given away. So we need to rewrite it so we can see the vertex. Now the only thing I do know is that it is going to open up and it is going to be very tall and very skinny. It's going to be very tall and very skinny because of that A value being 4. So if we're going to rewrite this in vertex form, first thing I'm going to do, first step, move the constant over. Y plus 5 equals 4x plus 24x. Next thing, take out the A. Take out the A. So y plus 5 equals 4 times x squared plus 24 divided by 4 is 6x. And I'm going to go ahead and save myself a step here and put those blanks in as to what I'm going to add to both sides. So cover up everything except for the parentheses here. And in the parentheses, we've got x squared plus 6x plus that blank. Half of 6 is 3. 3 squared is 9. We're going to add 9 inside of those parentheses. But what are we really adding to that right-hand side? We're really adding 4 times 9. And 4 times 9 is 36. So that is what we're going to put on the left-hand side in order to keep the equation balanced. So next, let's factor. So when we factor, we get 4 times factors of 9 that add up to 6, x plus 3 squared. And then, of course, on the left-hand side, 5 plus 36 is 41, y plus 41. And now we can drag that 41 back over. Y equals 4 times x plus 3 squared minus 41. So that means, and yes, you will need to identify your vertex on the test. Your vertex is at negative 3, negative 41. Your axis of symmetry, remember, it goes right through the vertex. It is just x equals negative 3. We've already talked about how it's going to open up. It's going to be tall and skinny. And if I were to draw a very, very rough sketch of this little parabola, back 3 down a bazillion down here at negative 341, this parabola would be so tall and skinny. It would also have its y-intercept at 0, negative 5. So, you know, we could put negative 5 about right there. Super tall, super skinny. Looks something like that. Now, what would the domain be? What would the domain be for every single parabola that we've ever talked about? It would be negative infinity to positive infinity. And the range on this guy, bottom to top, it starts down here at negative 41. So bracket negative 41 and everything bigger. So rewriting in vertex form, that's the last thing. Please study. Please watch all the other videos. Please do some practice problems. I'll see you in class.